In this video, I'm going to walk through CS4150, homework number 1, and also give a little bit of additional content to kind of get you ready for doing homework number 2. So in homework number 1, this is the assignment. In this assignment, you'll write a program that will produce the output shown in the following capture for my terminal window. So there it is. There's the output, okay, just from the command prompt. And I'm not going to go through the whole application description here, but essentially you see there's a relationship between the thickness of the printed circuit board, the minimum hole size that can be drilled using mechanical means. It's a simple ratio called the aspect ratio between the board thickness and hole diameter. So I told you in this case we'll have an aspect ratio of 6, so the hole should be a minimum size of 1/6 of the board thickness, whatever the thickness is. And I told you that the board thickness is going to start at 0.031 inches and then be multiples of that. So just like this right here, I told you to observe that this is just 0.031. That's 2 times 0.031, 3 times 0.031, etc., 4 times, 5 times. And so the drill thicknesses too are going to be that way. But I also wanted it laid out in this way so that there are 3 numbers after the decimal point. But I even gave you a line to print that out. Let's see if I can show you that. Down here at the bottom, I said this might be useful. You're free to use it, adapt it, whatever you want. But this would print the thickness and the drill if you provide thickness and minimum drill size as variables. Okay, so that's it. Also told you to put some things at the top. We'll talk about that as we get into it. And then the grading criteria. So that's the assignment. Let's see what the model solution looks like. Okay, so I've got a comment block at the top, and mine's a little different since this is the model solution. I put that first, but I do want to note you'll want to put your name, your 700 number, and then also some indication of the course, and also something about what program or problem you are solving. All that should be at the top, and I'll continue to help remind you of those things. So this is a very simple program. You notice it's 25 lines here in the editor, and that includes 7 lines of comments plus some blank lines here and there for clarity. Let's just walk through it. So we've defined here a public class which has the same name, PCB drill size, same name as the file, which is pcbdrillsize.java, as I specified in the assignment. And it has a single method, which is called main. And main, I have suggested to you, always has this form. It's the entry point of a program, and it always has an array of strings, which you can call whatever you want to, but it has an array of strings there. We didn't use any of the arguments, so no command line arguments in this program. I told you that the only things that I wanted you to put in that were just kind of like constants would be the thickness multiplier and the aspect ratio. Of course, you know you're going to iterate 5 times. I made that into a little variable here too. But there they are. I could have defined those as being static quantities as well, but since they're inside of the main, it doesn't really matter. It's a static method. Okay, so we have an output line that indicates the first part of the output that was specified, which is a header line. And then after that, we're expecting to have 5 lines of output. And I told you that I wanted you to use a for loop to do that. So here's a way that you could do that. Here is the beginning of the for loop. And you notice after the initial line here, we'll talk about that, we have the opening brace and then the close, because this for loop represents an entire block. And this part, even though it's outside of the initial brace, is really part of the definition of the block. So there's a block here that is going to be executed. It's being controlled by this for loop. And so what we do here is we state an initial condition, a condition that must exist in order for the code inside the block to be executed, and then a condition that we execute at the end of that block being executed. And so if you just look at the specification here, you can understand how this is going to work. We define an integer called I. It's very typical for a loop iterator to be called I. And we set it equal to 1 in this case. And as long as it is the case that I is less than or equal to number of thicknesses, what is that? Remember, that's up here, that's 5, okay? So as long as that is less than or equal to number of thicknesses, we're going to execute this code. And every time we get to the end of the block, down here where this closing brace is, we're going to execute this. This is the unary post-increment operator. It will increment the value of I so that I becomes I plus 1. So the first time through the loop, I equals 1, and we can check the condition. Is it the case that I is less than or equal to number of thicknesses, which is set to 5? And of course the answer is yes, because 1 is less than or equal to 5. So therefore, we're going to execute this code. And what we'll do is define another variable, which is the thickness that we're interested in at this particular time, and we'll define that as being I times the PCB thickness multiplier. Remember what that is? That's 0.031. So in other words, the first time, the thickness we're interested in happens to be 1 times 0.031. The minimum drill size then is the thickness divided by the aspect ratio. Here is the aspect ratio, 6, okay? And so the thickness divided by the aspect ratio is going to be the minimum drill size per the specifications in the assignment description. And then we simply output the thickness and the drill size. And let me explain to you how this line works right here. And I told you you could take it and just use it, and it would be helpful. It's fine for you to do that. But I'll give you an idea of what's going on. Within Java's string class, there's a method. You can think of it like a function or procedure in another language, but there's a method called format. And what format does is it receives a format string and some list of variables after it. And the variables are going to replace any of the things in the format string that have this form. They begin with a %, and then they have some specifications after them. This part right here is the part that will get replaced by one of the variables. And this part right here is the part that will get replaced by one of the variables. These two happen to be the same. And I won't go into a lot of detail. If you've used C before and C's printf and you've done some formatted output, you've seen something that looks just like this. This is a very similar functionality. But essentially what this says is we're going to output a number here, a floating point number, and after the decimal place, see the decimal point there, we'll allow exactly 3 characters. Okay, so you'll see how that results in the output. So we've got 2 placeholders that have a certain format. 2 numbers are going to go here, they're going to have a certain format. Then we just have to supply the numbers. The numbers are thickness and min drill size, okay, that we've computed here. So we'll see what that output looks like in a moment, and we'll see how that does exactly what we've indicated and looks like the sample. Now then, we've gotten to the bottom of the first iteration of the loop, and of course we have produced one line of output in our table that says thickness, and it will say, well, 1 times 0.031, which is what that value for thickness is, right? So it's going to say thickness it's going to say 0.031 semicolon, and then it will say minimum drill colon, and it will say whatever that minimum drill size is. Now it's 0.031 divided by 6, so I'm expecting it to be about 0.005 would be the closest. Okay, so 5/1000ths of an inch. That's the first line. Now then, remember we get to the bottom here, I gets incremented, so I equals I plus 1. Basically, that's what this means. Okay, so now remember I was 1, now it's 2. So, is it the case, now that I is 2, we're back up at this line doing this comparison that you see right here. Is it the case that I is less than or equal to number of thicknesses? In other words, is it less than or equal to 5? It was 1, now it's 2. Is 2 still less than or equal to 5? Yes, it is, so we do it again. But notice now the difference is that thickness is set to now 2 times the PCB thickness multiplier. So see, it's now 2 times 0.031, so that'll be 0.062, won't it? And of course it is the case also that the minimum drill size will change because it depends upon thickness, as you see here. It'll be thickness divided by aspect ratio. Now thickness is 0.062. So that means the min drill size will also increase by a factor of 2. Now there are other ways you could have done this calculation. You could have remembered the minimum drill size. You could have calculated it for the first thickness and then just increased it each time by some ratio. There are other ways you could do it, but this to me is the most straightforward. And so then the second time through the loop, it will also print a line of output. And it will do it again and again and again, and then it won't do it again. Why? Because at some point after I++, I becomes 6. And when I equals 6, we determine is I less than or equal to number of thicknesses, which is set to 5, right? So is 6 less than or equal to 5? It is not, so it will not execute that code anymore, and the for loop is done. And it will resume execution after the line that you see the cursor on right now. Since there's nothing else to do, there's no other code to execute before the end of the main, then this program completes its execution right here. It's finished. Let's just have a look at what that looks like. If I list my directory, I have a few files in here. One of them is PCBDrillSize.java. You see that here. So I will run the Java compiler on PCBDrillSize.java, just like so. No news is good news. That means the program has compiled. And I can verify that if I want to, just by seeing that there is a .class file. If I do a directory, you see it right here, PCBDrillSize.class. See that? Now we need to run that using the Java virtual machine, and so that's just the command Java, not Java-C. And it'll be PCBDrillSize, but you don't put the .class after it. You don't put anything, so it's just like this. And we run that, and there's our output. Remember, we had our first line over here, and then 5 times through the loop, each time increasing the thickness by another 0.031. So here it is, 0.031, 0.062, 0.093, 0.124, 0.155, and then here's the corresponding minimum drill size. So hopefully that was helpful. That's a lot of time spent on the one program, but I want to make sure everyone understands how this one works. And if you're having any trouble understanding this and understanding how the for loop works in particular, you should talk to me about that, and I will work as much as I can to help you with that. So because we're going to move on and really need to know this stuff pretty well. In the next video, I'll give you a little introduction to our homework assignment number 2, and walk through a program that's a little similar, so I can show you some things that you might find helpful for program number 2.